So in the previous class we discussed about what is system, what are the different types of system. There we discussed what is open system, closed system and isolated system. Dear students, as I told, today's class I am going to discuss what is closed system in detail. Okay, with some engineering and live applications. So what is closed system? Closed system is a system in which energy, you can see here now, closed system is a system in which energy can crosses the system boundary but no mass transfer. That type of system you can call it as a closed system. Closed system is a system in which energy may crosses the system boundary but mass remains constant. That type of system you can call it as a closed system. How it is closed system, that we already discussed. The system, it is going to have a certain quantity of mass, okay, and it is surrounded by a layer. That layer we call it as a system boundary. So as I told, in this closed system only energy will enter into the system or it may exit out of the system, but mass remains constant. If it's so, that type of system you can call it as a closed system. So closed system is system in which energy may crosses the system boundary but mass remains constant. That type of system you can call it as a closed system. So to understand better, what I will do, I will take an engineering application, that is IC engine. That too, in IC engine I will take piston and cylinder arrangement for better understanding of closed system. So you can see here, dear students, I am going to take a hot gas here into the cylinder. Okay, so it is having a pressure P1 and volume V1. So I will write it here. Okay, so pressure P1, volume V1, temperature T1. This hot gas is surrounded by a layer or envelope or enclosure. That enclosure we can call it as a system boundary. Okay, this is what cylinder and this is piston. Okay, and you can see both inlet valve and outlet valves are closed. Okay, inside the cylinder hot gas is there. Okay, when it is a hot gas, assume that the hot gas temperature is 80 degrees Celsius. Okay, then surrounding temperature is 30 degrees Celsius. Obviously heat will move from high temperature region to low temperature region. So when it is heat is moving from high temperature region to low temperature region, means heat energy is transferring, but when it is completely closed, there is no provision for mass transfer. Hence there is no mass transfer, but only heat energy is transferring. If only heat energy is transferring but no mass transfer in a system, that type of system you can call it as a closed system. So you can see here now, closed system is a system in which only energy can transfer but there is no mass transfer. That is known to be closed system. Now, so to understand this closed system better, I am going to consider some more examples. There we are going to get different boundaries. Those boundaries are fixed boundary and moving boundary. Okay, when it comes to closed system, it is having different boundaries. One is fixed boundary, another one is moving boundary. So what is fixed boundary? Dear students, I can take it here, piston and cylinder arrangement. Okay, I am going to take a piston and cylinder arrangement. It is having a gas, normal gas at a temperature at a condition of 30 degrees Celsius, at a temperature of 30 degrees Celsius, which gas having pressure P1, volume V1 and temperature T1. So let us take the mass of gas is 2 kg, the volume at initial condition is 1 meter. Okay, 1 meter cube. You can see now, this is what cylinder wall, this is side 1 and this is side 2, this is side 3 and this is side 4. But 1, 2, 3 are sides are fixed. Okay, this gas is surrounded by a layer. That layer we can call it as a boundary. So I am going to call it as a fixed boundary. Why it is fixed boundary? The piston is at this particular point, the gas is there, then all surroundings are, all sides are fixed, but there is no movement of boundary. If the boundary is not at all moving, if it is fixed, that boundary we can call it as a fixed boundary. So the gas having in a boundary, right, that boundary is not at all moving. In this particular case, that case I can call it as a case 1. In case 1, the boundary is not at all moving, it is fixed. That boundary we can call it as a fixed boundary. So I will take a second case. I will call it as a case 2. In case 2, the same cylinder piston arrangement and same gas I will take it here, and I will heat the gas with the help of a heat source. When you are going to supply certain amount of heat to the gas, right, it will try to expand. The will try to expand, and it is going to create explosive force over the surface of the piston. It is going to create, or it is going to exert explosive force over the surface of the piston. Hence the piston will start to move from point 1 to point 2. When the piston moved from point 1 to point 2, the volume is going to increase. Let us take volume is increased to 3 meter cube, but mass remains constant. The mass is not at all changing, 2 kg only. But when the piston moved from point 1 to point 2, the volume increases, right? That means what? The boundary is moving from point 1 to point 2. If the boundary is moved, that boundary we can call it as a moving boundary. But you can see here now, but mass is not at all moving. Mass is constant. The only boundary is moving. Hence we can say closed system. This is closed system with moving boundary. Second case. Okay, so now I will move towards third case. The same piston cylinder arrangement I will take it here now. Anyway, the gas gets heated. Then I will give a small opening to that gas. Then that gas will try to come out, and it will enter into the surrounding. Then that hot gas entering into the surrounding, hot gas you can call, hot gas entering into the surrounding, but we are not at all seeing the boundary. What we can do? We can only imagine there is a boundary, but we can't see it physically. If the boundary is not at all visible, if you are going to imagine that boundary, then that boundary you can call it as a imaginary boundary. That boundary you can call it as a imaginary boundary. Live example for that imaginary boundary is, you can take an IC engine. From the IC engine combustion, hot gases we can call exhaust emissions, they are coming out, right? But when they are coming out and they are entering into the environment or surrounding, okay, but they are having a boundary, but that boundary is not at all visible, but only we can imagine. If we are imagining a boundary, then that boundary we can call it as a imaginary boundary. If you are imagining a boundary, then that boundary you can call it as a imaginary boundary. Okay, dear students, these are the examples you can see. For your exam purpose, if you want to draw and explain what is moving boundary, fixed boundary, imaginary boundary, you can draw these two sketches. Here the boundary is fixed. That fixed boundary we can call it as a real boundary. That real boundary or fixed boundary is nothing but what? Physically it is available. Physically we can see the boundary. If you are physically seeing the boundary, that boundary we can call it as a real boundary. When the exhaust emissions coming out of the exhaust manifold, right, that will enters into the surrounding. When it is entering into the surrounding, we can imagine there is a boundary. That boundary we can call it as a imaginary boundary. Okay, now I will take some more examples for this fixed or real boundary and imaginary boundary. I will take one more engineering example, that is nozzle. Assume that in nozzle the steam is moving. When the steam is moving, right, through a nozzle surface, we can say nozzle wall or nozzle surface. That means what? There is a fixed boundary that we can visible. That boundary we can call it as a real boundary. When the steam is getting out of this nozzle, right, when it is coming out of this nozzle, but the steam having a boundary, but we are not at all seeing that. We are unable to see that boundary, but we can imagine that boundary. That boundary we can call it as a imaginary boundary. So example, you can take a nozzle. Assume that in nozzle steam is moving. That's one example you can take. One more example you can see now. That is what I told. Moving boundary and fixed boundary, piston and cylinder arrangement, dear students. One example already I discussed. Okay, this is second engineering application. This is first engineering application, second engineering applications, and we can take third engineering applications here, compressor. When air is compressed into the compressor, then it will be stored into the tank. When the gas is leaked, that means hot gas is coming out, right? That means what? Hot gas having in a boundary, that boundary we can call it as a imaginary boundary. But whenever the hot gas is stored inside this tank, right, that is having a fixed boundary, we can call it as a fixed boundary, or we can see that physically we can see the boundary, then that boundary we can call it as a real boundary. If gas leaks, hot gas is coming out of the tank, that means what? We can call it as a imaginary boundary. That gas having in a boundary, that boundary we can call it as a imaginary boundary, dear students. Okay, this is about closed system. What are the engineering application of closed system? And when it comes to closed system, it is having two boundaries. One is fixed boundary and moving boundary. One more, we can say imaginary boundary. What these all we have discussed with some engineering application. Okay, so I'm going to stop here. Thank you for your patient listening. Okay, I request you please subscribe my channel, share it to your friends, and do like and comment and support the Anveshana Academy. Thank you.